let's take our geometer, and let me see if I can find which one I want. And then we're going to take the bottom side and we're going to extend it out this way and put an arrow on it. And we're going to number angles. 1, 2, ooh, let me scoot over. 1, 2, 3, 4. And then I'll get ahead of you, but I'll let you catch up. An exterior. So actually we're just doing 2 examples. This is just a picture. An exterior angle of a triangle. Oh, this isn't the definition. We're going to draw the picture up there. Equals the sum of the 2 remote interior. I got to put it in there. The measure of an angle, an exterior angle of a triangle equals the sum of the 2 remote interior. Sum of the measures of, y'all are gonna die. I know you hate when I start adding stuff to it. The sum of the measures, I gotta write it mathematically correct, I just can't stand it, of the 2 remote interior angles. We got to talk about where an exterior angle is. It's pretty easy, but you have to understand that it's not, if I extend both of these, an angle that's a vertical angle, like if I extended this and I had an angle right here, see, it would be the same as 3 because it would be vertical angle. But an exterior angle is found when you take one of the sides and extend it and you have an angle on a straight, you know, it's a linear pair. You're making a linear pair of one of your angles. So this is an exterior angle. Now what do we mean by interior angles? What do you think we mean? Which ones? Yeah, 1, 2, and 3. But they call them the 2 remote ones. Now before I do that, let me ask you a question. What's the sum of 1, 2, and 3? 180. Now, what we're going to say is that the measure of angle 3 and 4 is also 180. That's how you'd actually go about proving it. And then you would subtract angle 3 from both sides. You can make an equation out of it. I was going to do that. I don't want to eat up your time. But what we're going to find is, what it says, this says, is the measure of angle 4 equals the measure of angle 1 plus the measure of angle 2. Now, here's the deal. They're called remote ones. Look at angle 4. When I think of the word remote, not remote like a noun that is your, you know, I'm remote, I'm thinking of, I would hear it in a word like a remote island or something like that. If you've ever heard, so, you know, a deserted remote island, which means it's just out there, right? So remote interior are the 2. Every time you have an exterior angle, you're going to have 2 of these that are away from it. Not the one that it's adjacent to, but these 2. So 1 and 2 would be its 2 exterior, 2 remote, am I on screen? There we go. 2 remote interior angles. That's these 2, 1 and 2. So the measure of angle 4 equals the measure of 1 and 2. Now, one like this first one, let's do the same triangle, but we're going to extend a different side. Okay, this time I'm going to take the edge of my geometer and I'm going to extend this one. And we'll talk about how most people would work it. I'm going to let this one be 110 degrees. I'm going to let this one be 84 degrees. And I'm going to let this one be X. If I had given you a problem like this on your classwork in lesson 13, if any of you've worked on 13, which I think some of you have, am I talking about the right lesson? Yes. If I'd have given you a problem like that and asked you what this angle is, how would you have worked it? I think this is the way most people would work it. What's the 3 angles in a triangle add up to? 180. Do you know this one? If this one's 110, what's that one? Isn't that a linear pair? And that's 70, right? So you would do 180 minus 84 minus 70, and you get your answer. That's the way most people on the ACT, if you had one like that, would work it. the rule says. Does it work the same way? Yes. Is it a little faster? I don't know. This one says the exterior angle is equal to the sum of its two remote interiors. So 110 equals 84 plus x. Subtract 84. I think it's probably a little bit faster, and you get x equals 26 degrees. And so that one you could do it 180 in the triangle, do the linear pair. So I'm not telling you have, do you have to use the rule? No, you have to do it mathematically correct. So if you do a problem like that, 180 in a triangle, that's awesome. That's how they prove it anyway. And then the last one, we're going to use that right triangle right under that scalene one. I don't think we're going to call it a right triangle. No, it's not. So we're not going to put a right angle here. It is, but we're going to use it just generically. And we're going to extend this one. This is a rule that you just don't use that often, and then you forget about it. We're going to let this angle right here be 28 degrees. We're going to let this one, and I'm going to write it outside because I don't have a lot of room. This angle right here is going to be 1 plus 11x degrees. And we're going to let this one out here be 15x minus 3 degrees. Now, I won't tell you that it's impossible to do it if you don't know this rule, but you would have a lot of work because you would have to do, to find this one, you would have to do 180 minus that. Okay? So you'd have to distribute the negative, get a number, get a thing with an x in here, and then you'd have to say all three of these add up to 180. So that's where it gets a little messy. But try the new rule. The exterior one, which is this one, equals the sum of the two remote ones, which is 28 and 1 plus 11x. So these are the ones, I'm going to put a star by it, because those are the ones you'll forget. I'll put a star there so that when you get ready to take the quiz, this is what you want to make sure you know do. These you can do. Y'all can do that. It's arithmetic. This one, I'm going to clean up the right side. I have, looks like 29 plus 11x. I'm going to move the 3. I don't know. Oh, I like to move my x's first. I'm going to move the 11x first. You don't make as many mistakes if you move the x's first, and that's our goal, isn't it? Then I'm going to add the 3, and I get 4x equals 32, x equals 8.